Hello all. So this video is regarding the OTEC power desalination. So before we go into the OTEC power desalination, I wanted to take you through some of the basic concepts for the OTEC power desalination. So starting with the second law of thermodynamics, which is basically a Kelvin-Planck statement, which says it is impossible to construct a device which operate in a cycle, produce work continuously while interacting with a single thermal reservoir. Basically, what it means that without two temperature we cannot have a heat engine. So we should have a lower temperature and a higher temperature, and if we found this lower and higher temperature anywhere, we can definitely fit an engine which can produce a work. If you see in ocean also, we have the lower temperature at the bottom surface and the higher temperature on the ocean surface, and basically we can fit out an heat engine, but again the efficiency will be very low. This is how the Kelvin Planck provide the concept of work producing device, which is heat engine. So basically it's a fundamental thing that OTEC is theoretically possible. Now let's come out the Carnot cycle. It is used as standard performance for all heat engine operating between high temperature and low temperature. So if we have a high temperature and low temperature engine, and which is basically efficiency, we can calculate like 1 minus TL by T higher. Assume that ocean surface is 30 degree and deep water surface temperature is 7 degree, then the Carnot efficiency is 7.6%, which means basically if we put a 1 kilowatt heat input, we will only get 76 watt of power output, only if system has no loss present in it. So basically it tells that Carnot cycle have a maximum efficiency of all the engine, so you cannot get more efficiency than the Carnot cycle. So that's the Carnot efficiency, that 7.6% is the maximum efficiency you can achieve if we create a plant using the OTEC powered desalination. Now I want you to take through the vapor pressure as well. What is the vapor pressure? It is basic pressure exerting by the vapor on the liquid, which tells about how much pressure is there. So let's take a fundamental example. So let's water boil at 100 degrees Celsius but at 1 atmospheric pressure. So if we reduce the pressure, atmospheric pressure, the boiling point also will reduce, and if we increase atmospheric pressure, the boiling point will also increase. So let's suppose if I want to boil a temperature at 25 degrees Celsius, is it possible? Yes, it is possible, only if we can reduce the pressure up to the vapor pressure of 25 degrees Celsius, which is around 2.5%. If you see on the graph, at 100 degrees Celsius, 1 atmosphere pressure is there, and if you go down like 50, the pressure will decrease. So that's how it goes. Now coming to the next is the heat exchanger. I just wanted to highlight that what is heat exchanger. It is the general function of heat exchanger is to transfer heat from one fluid to another. We can have different type of heat exchanger: parallel flow, counter flow, and mixed flow. Only the use of the heat exchanger is to exchange the heat between the two medium. So that's the use of heat exchanger. Coming to the next is the turbine. Again, the turbine is a rotating part which convert kinetic energy of working fluid into the mechanical energy or electrical energy. So this could be a kinetic or pressure energy. So both the type of energy we can extract it from the turbine and can generate the power. I hope all the small things has been covered before going into the OTEC power desalination, how the plant will work. So if you see, there's the ocean surface at 30 degrees Celsius, and the deep ocean, if you go, will go like 7 degrees Celsius. For that, I think you need to go 4 kilometer deep into the ocean, then you will get the 7 degree. So what we need to do is, we have a vacuum chamber basically where we create a vacuum pressure. Let's suppose we create a 2 kilopascal vacuum into the chamber, which means that approximately with 2 kilopascal, 25 to 30 degrees Celsius temperature will get evaporated. So we have vacuum chamber which is directly taking water from the ocean at 30 degree and get evaporated because the vapor pressure is very low. And once it gets evaporated, we have the moisture, or you can say a kind of steam, which is into the vacuum chamber, and the rest of the water will go back, flown back to the ocean, which is more like which is going out is more in salinity quantity, because the water moisture we have extracted from the ocean water. So if we have this moisture or steam at 25 degrees Celsius, we can take this steam to run the turbine. And what happens to run the turbine? Basically we have the generator, and with this generation we can generate the power, and this power generation basically can be used to run all the pumps into the system and get the whole system self-powered. And once the electricity is generated, once the exit of the steam will go into the heat exchanger basically. And here, let's suppose we got it 30 degrees Celsius and some temperature top, we got it 25 degree and 25 to 20 degree, and we still have 7 degrees Celsius. So the delta is very small. So why we want a heat exchanger here is basically the left out steam, we wanted it to get condensed. So this is basically a condenser type of heat exchanger where the steam will get condensed into the fresh water. So whatever condense out will use as a fresh water for the people who can use it for drinking purpose. And what happens to this water flow, the 7 degree, it will go inside it. It will cool down or condense the steam which is coming out from the turbine, and once this will take the heat from the steam and this will go back into the ocean. So let's suppose there's a 7 degree and the temperature rise will be like 10 to 11 degree, which will goes back to the ocean. So that's how the OTEC power desalination works. If you have any question, you can write down in the comment. And yeah, I'm new to the channel, please subscribe the channel. Thank you all.